modus ponens, it says that if P and P conditional Q is true, then we can infer, that means we can conclude that Q will be true. That is, it will be represented something like this, P conditional Q comma P, then we can derive Q. So that will let us discuss with one example. There is one statement, if I am sleepy, then I go to bed. So you know that this particular statement, how we are going to convert it into symbolic form. So if then means it is represented by a conditional statement. And there is one more statement that I am sleepy. Okay, so if I am sleepy, yes, definitely I will go to bed. That means from these two statements we are going to infer Q. So in that way this modus ponens work. Okay, the next one is modus tollens. So this rule states that if P conditional Q is true and negation Q is true, then that we can say that negation P is also true. That is the same statement you see here. If I am sleepy, then I go to bed. That is P conditional Q, we know. We are saying that negation Q. That is, I do not go to bed. Yes, if I do not go to bed means negation P. That is, that infers that I am not sleeping. So this is called as the modus tollens rule. Next one, hypothesis syllogism. So here, this rule states that it's like a transitive property. If it is P conditional R and is true whenever P conditional Q is true and Q conditional R is true. And it is represented by, see here you can, so see here one statement. If you have my home key, then you can unlock my home. That is one P conditional Q. If you can unlock my home, then you can take my money. That is Q conditional R. Then the conclusion is, if you have my home key, then you can take my money. So that is what the hypothetical syllogism. That means if you have these two statements, yes, obviously you can derive the third statement. That is what we call it as the hypothetical syllogism. Then disjunctive syllogism. So this rule states that if PRQ is true and negation P is true, okay, then Q will be true. That is, there is one statement that today is Sunday or Monday, so which is represented as PRQ. Okay, then today is not Sunday, that is negation P, and today is Monday. Yes, if today is not Sunday means the conclusion is yes, of course it is today is Monday. So that is what the disjunctive syllogism. So PRQ comma negation P derives Q. Next, addition principle, a simple, it's a common inference rule, and it states that P is true, then PRQ will be true. See, there are two statements. I have a vanilla ice cream, I have chocolate ice cream. So when I have both, I can say that I have vanilla or chocolate ice cream, which is from PRQ you can derive PRQ. That is what this addition principle. So along with this, there are two more, that is simplification and resolution. So this simplification is P and Q can be written as Q or P. So when in the derivation process there comes across P and Q, so that P and Q can be written as either P or Q. That is called as the simplification. Okay, and coming to resolution here, I don't want to discuss here this resolution. With one example I will make you clear what are the resolution facts and how we are going to derive conclusions from that resolution. Just meanwhile, just only remember this formula, but with one example I will make you clear what is this resolution. See here, what is this resolution principle is, given a set S of classes, then the direction of this C from S is a finite sequences of classes such that each Ci is either a class in S or a resolvent of classes preceding C and Ck. Just I keep on reading this, you can't understand. So let us discuss one example. This is P conditional Q formula, like S conditional negation R. I have written negation S or negation R. Then in the earlier simplification formula, I told you that P and S can be represented as P and S. So it will become class 3, class 4. So now from these three premises, we have converted into 4 classes. Now we have to derive new classes from the existing one, and we have to prove that there is a conclusion for this. See here, how we are going to take two classes is in such a way that in both the classes one variable should match. So if you take this and that to one positive and one negative, then we are going to get some conclusion. See here, I am going to take C1 and C2. Why C1 and C2 is, see here R is there, here negation R is there. So when I introduce these two, R and negation R gets cancelled, then the result will be negation P, R, Q, R, negation S. Yes, that is the result, and this is the class phi. Okay. So this is the class C phi. Next one, so the resultant is negation P, Q, R, negation S. So next, let us introduce another one. So we have resultant as negation P, R, Q, R, S. Okay. So let us here introduce negation, this is C3. Okay, C3 and C5. So here P is there, here negation P is there. That gets cancelled. Then we will have a Q and negation S. The resultant is Q and negation S. And the next only the clause we remaining is S. So Q, R, negation S, and S, negation S, and X gets cancelled. The resultant is C7. Therefore, here for this particular set of premises, the conclusion is the Q. So in this way, the resolution principle works. So in the coming classes, next classes, let us discuss in depth about this resolution refutation with examples. Thank you.